Hello everyone, my name is Neeraj and today we are going to discuss about AWS Aurora Database. So, we are going to discuss what is Aurora Cluster and the lab on it. So, AWS Aurora is a database which use MySQL or PostgreSQL engine for their database. So Aurora is generally a cluster provide an infrastructure where they use the engine of MySQL database or a PostgreSQL database. So when you want to create an Aurora cluster, it will ask which engine you want to use. So here we go in a detail. We have Aurora cluster. Aurora is a database technology in AWS. It's not an open source. Amazon Aurora is a fully managed relational database engine that compatible with the MySQL and PostgreSQL. Compatible means infrastructure is they have the infrastructure capability, but engine they will use of the MySQL. Means that there is no change in the code. If you have any MySQL database running and if you want to put in Aurora cluster, the application code will not change. Aurora is a part of managed database service of Amazon RDS. Aurora includes a high performance storage subsystem. The automatic clustering, replication and the storage allocation make it simple, cost effective to set up, operate and scale your largest MySQL and PostgreSQL deployment. You can bring your data from Amazon RDS for MySQL and Amazon RDS for PostgreSQL into Aurora by creating and restoring snapshot or by setting up one-way replication. Aurora can use push button migration tool to convert your existing Amazon RDS for MySQL and Amazon RDS for PostgreSQL application to Aurora. Aurora is a cloud optimized and claim 5x performance improvement over MySQL on RDS and over 3x performance on Postgre on RDS. Means that if you have any database instance, MySQL instance running on RDS, it will use, if you put the same thing in Aurora, it will use a 5x performance, and if for the Postgres it will give 3x performance. Aurora can have a 15 replicate while MySQL have a 5, and the replication process is faster. That's AWS claim that in the Aurora cluster it will be the replication will be faster. So just let's understand how the Aurora cluster will work. So suppose you want to launch an Aurora cluster. So suppose you have, what you will be do is, here one more thing, when you launch an Aurora cluster, suppose you want to run 2 instance, 3 instance. The interesting part is that only one instance will work as a master. Rest other will not work as a slave. It will work as a read replica. So in Aurora cluster, you will have a one master and the rest will be a replication instance or replica instance. So the master will have only the will have a privilege to do read write operation. Rest other instance will have only the read operation. And if the failover, now you will have a question, what will happen if the master goes down? One of the replica will convert into master and it will take the read write responsibility. But again you have a question, you are saying about read, and why AWS claim that replication is faster? Because subsystem storage. In previous slide there is a line faster sub storage system. The sub storage system across the availability zone is shared. See here, suppose in Aurora database cluster you will have ability zone A, B and C in one of the region. Now you will have a primary instance, Aurora replica and Aurora replicant, secondary and third sorry, ability zone. You will have, this is the game changer in their architecture. It's a cluster volume 2 to 4 and 2 6. So why I have put 6 here? I have put intentionally because whenever you put a data in Aurora cluster, it create a 6 copy, keep 2 copy in each separate availability zone. Even you have a single instance or a multi-instance, if you have created an Aurora cluster and if you want to put your data, the data would be copied. Data would have a 6 copy and 2 copy each in each availability zone, and they have a self-healing capacity. Like if there is a block, there is a corruption happens, it will be self-healed by other copies. So the master can read on all the copies, master write in all the copies, only the read will happen to all these three. You can do the reading through the master also, read replica also, but writing will be done through the master only. This is the basic architecture of a Aurora cluster. So if a MySQL database running an RDS instance, and in that if you want to create a read replica, they have a separate storage. So it will go through the network, it will take time. Here they have a shared kind of thing, they have a shared storage. In all three availability zone they have created. It's very simple. In a lot of hard disks, we create a logical disk group if you are belong to an Oracle architecture, and then we create the SM disk group. So similarly it will be shared. So feature of Aurora cluster, it is automatic failover. So if the master goes down, one of the read replica will convert into the master. You have an option to put on priority. What I will do is we'll directly go to the lab and first we'll launch an Aurora cluster because it will take time. Let's go here. If you want, again I can show you. You put RDS to database. So let's create a database. We have an Amazon Aurora. Now see here, edition. In addition, you can choose either a MySQL compatibility or Postgre compatibility. If you go to the MySQL compatibility, you have to choose which MySQL version you want to use, because there is interesting point. According to the MySQL version also, there are some specific Aurora cluster feature which depend upon it. So here if you go to MySQL, choose 10, just 5.6.10, see here, database location, regional or global. What is regional and global? Just keep in your mind, we'll discuss. And here it will come, regional database supported, multi-writer. What is multi-writer? I will come on that. One writer multi-parallel query, this will be supported. See this, database feature, one writer, multiple, serverless, multi-writer, all this feature will be depend upon. So let's here and go and choose the latest one, MySQL 5.7. Nothing has come. Here we'll use my Aurora DB. Here again similar, master user and the password. Now DB instance size, like which EC2 class you want to choose, and then if you want to create multi-easy deployment, create an Aurora read replica, reader node in a different availability zone, yes. Default VPC, yes. Choose existing one. I think I have already created one MySQL RDC Gmo. Basically we have to give this 3306 that process. Then database authentication, password, additional configuration very similar to my DB instance is equal to my Aurora DB. Yeah, identifier is same. Cluster, the default parameter group, optional group, failover priority, tier 1 0 is a higher priority. So tier 1 priority, nearby things will be replica will be get uploaded. See backup, copy as a 1-day backup, encryption, no I don't want encryption, let it be. There is called backtracing, and backtracing will be for 72 hours. What is backtracing? Will come to know, let it be. Enable performance inside, no I don't want. Enhanced monitoring, let it be, don't use. You can put audit log, error log, general log, slow log. Minor upgrade, no preference. Detection protection, no. And create the database. So 3-4 point we learn. One is what is global versus regional cluster, what is serverless, what is multi-writer, and backtracing. Sorry, registration has failed. Cannot get because okay, that is a problem because EC2 you can launch 20, but here as we are creating read replica, there are 2. So depend upon the class, the free tier has some limitations. So what we can do is we can go here in the class section. I mean, what is this? If you go and check in my EC2 video, you will come to know, like by default you can launch 20, maximum 20 EC2 server in one region, and in that also according to the instance class there is a limitation. So most of the free tiers with some higher, you have a limitation to go with the 1. It is creating MySQL DB. This is the cluster name and this is the instance. Only the writer will coming up, reader will not coming up, because we'll check that. We'll use another instance for the read replica. So till now we'll go to our slide. See here. So what is the feature of Aurora? First is automatic failover. Now you will have a question here. Just saw you have a cluster name and only one instance is up, and it has a writer, means read and write will be happen through only one instance, and you have only one instance running in Aurora cluster. If that instance will goes down, what will happen? Don't worry, it will automatically create a new instance. It will not switch, it will create a new instance. So automatic failover, backup and recovery, isolation and security, industry compliance, push button scaling, automatic patching with a zero downtime, you don't have to bother about, advanced monitoring, routing maintenance, backtrace, restore database at any point of time without using backup. Like if you are an Oracle DBA, you know what is called flashback database, but you don't have to go to that much process you have to follow. Here what you have to do is just one click. If you want to put your whole database in particular point in time, you can go back, but there is a limitation. You can go back up to 72 hours by default. 6 copy of your data across 3 availability zone will be present. 4 copy out of 6 need for the write, like quorum concurrency. I mean, if all the 6 copies present in the store, if there's an update is happening, if the 4 is completed, then write will complete. It will not wait for all the 6 to complete. For the read, out of 6, 3 copies matching, read will fetch to you. That's all. Self-healing with a peer-to-peer replication storage is stripped across hundreds of volumes. One Aurora instance take write or automatic failover for the master in less than 30 seconds. Master plus up to 15 Aurora read replica can serve as a read. Support for cross-region replication. Yes, it supports. Now feature is security in Aurora DB. Obvious, we saw the encryption. So encryption at rest by KMS. Automatic backup snapshot and replica also encrypted. If you create Aurora database with an encryption, automatic backup, also the read replica, both will be encrypted. Encryption in the flight SSL, like SSL connection, you can the way we do with the RDS, you can do here. Authentication using IAM also you can do it, like who will use my cluster, and then as a user who will log in. Security group, yes, because through the security group you can filter the inbound traffic. Like RDS, you cannot do SSH with, you will not get any operating system access here. Amazon Aurora DB cluster supports socket layer connection from application using same process as a public key as an Amazon RDS DB instance, like SSL socket connection we used to do. Similarly, we can do with an Aurora cluster. Now, what are the instances available in Aurora DB cluster? Primary DB instance, support the read-write operation and perform all the data modification to the cluster volume. Each Aurora DB cluster has a one primary DB instance. And what are the Aurora replica? Connect to the same storage volume. Yes, because shared volume is there. Connect to same storage volume as a primary DB instance and support only read operation. Each Aurora cluster can have up to 15 Aurora cluster replica in addition to the primary instance. So it can have a 15. Maintain a high availability by locating Aurora replica in the separate availability zone. So even the whole availability zone get you can say fail, your database or cluster will still up, your application will still access. So highly available, highly scalable. Aurora automatically failover to an Aurora replica in case the primary DB instance become unavailable. When data is written to primary DB instance, Aurora synchronously replicate the data across the availability zone to the 6 storage node associated with your cluster volume. See, if you have watched my previous video, what is I like AWS RDS. In that there is a feature called multi-AZ deployment and the read replica. And what is the major difference between multi-AZ deployment and the read replica? In a multi-AZ deployment, it happens synchronous replication. In a read replica, it happens asynchronous replication. Why it happens asynchronous replication? Because storage itself is a different, separate. But in Aurora cluster, your storage is same. It's shared across the availability zone. That is the reason here document says it's a synchronous replication. AWS says in practical near synchronous replication, but it will be never asynchronous. Now the important point, that's the reason I told, like when you choose while launching an Aurora cluster, if you choose MySQL version, the feature will get changed. So if there is a latest feature called that is called multi-master Aurora cluster. Means that there is no concept of read replica and the master. Every instance will do a read write operation. That is called multi-master cluster. So for the Aurora multi-master cluster, all DB instances have a read write capacity. In this case, distinction between the primary instance and Aurora replica doesn't apply. But you will ask me that I launch and cluster, I never seen that that option. Yeah, it was there. In right hand side there was an option, and in that there was a version. Like according to the MySQL version, only one version is available. For that, this multi-master application, multi-master cluster can deploy, not all the version of MySQL. So two-way, your Aurora cluster has a features. It is depend upon two database engine, either a MySQL and PostgreSQL. Within that, according to their engine version, some of the features supported or not supported. And when you choose the version, it will show in the right hand side. So Aurora DB cluster has a two type of architecture, where you have a one master, rather will be read replica, and it will depend upon according to the MySQL version, and it has only one MySQL version where it supported multi-master cluster, where every instance has a read write capacity. Backup. Aurora backup your cluster volume automatically and retain stored data in the length of the backup retention period. And what is the backup retention period? Backup continuous and incremental backup at any point of retention period. No performance impact or interruption of a database service occur at the backup is retained. Being you can specify the backup retention period from 1 day to 35 days when you create or modify the cluster. If you want to retain a backup beyond the backup retention period, you can also take a snapshot manually. For Aurora DB cluster, the default backup retention period is 1 day, regardless of how DB cluster is created. So how you are creating a DB cluster, default retention period is 1 day. You cannot disable the automatic backup in Aurora. The backup retention period for Aurora is managed by DB cluster. So like on RDS, if you want to put 0, the automatic backup will not happen. But this is not the case with Aurora. You have to. Understanding of Aurora backup storage unit. Like if you have configured an Aurora backup, how you will understand in the CloudWatch, the log will get generated and you will have a 3 matrix: backup retention period stored use, snapshot stored use, and total backup stored bill. Using that you can calculate the Aurora backup storage used. Like you have to calculate, am I right? Sorry. Because in Aurora cluster, you are have you ever seen while launching this DB cluster we have anywhere we have assumed any kind of a storage? No, it doesn't. Because Aurora cluster has a very good feature is the way you will use the data, may store the data, it will acquire the storage, and according to that it will charge. So Aurora DB cluster endpoint, what is that? So in RDS, if you want to log into an database, there is called database endpoint, and that database endpoint you can use as a host name. How we are going to work here? In Aurora cluster, we have a endpoint of a different type. What are those endpoints? Cluster endpoint, a reader endpoint, custom endpoint, and instance endpoint. Cluster endpoint means you put the cluster endpoint, you will log in through the cluster endpoint. So it kind of load balance, it is a read write operation both. So for the read it will go to the master, for the write it may go to the master, it may go to the other replicate. Reader endpoint means if you want to do a reader endpoint, you have a 3 replica behind that, 3 replica instance are running. It will go to any of the instance, it will do the work for you. Custom means you can create your custom according to your DNS name, also you can create your custom endpoints. Instance endpoints, if you want to go to the specific instance, if you want to connect as a suppose it is a reader, if you want to connect to that specific instance, you can connect very well. But if that instance goes down, your connection will not switch, or you will get say database doesn't exist or database not available. That kind of error you will get. So there are 4 type of endpoint you will get it. CPT here in detail, also known as a reader endpoint, writer endpoint. Endpoint is only used can perform the operation as reader. Reader endpoint, we have given all the points here. Custom endpoints. A custom endpoint for Aurora cluster represent the set of DB instance that you choose. You define which instance endpoint refer to. You decide what purpose the endpoint work. Instance is, it is very specific case. Like instance endpoint for the specific DB instance within Aurora cluster, the DB instance in DB cluster has its own unique instance endpoint. The instance endpoint provide direct control over the connection. For the scenario where you do not want to use cluster endpoint or customer endpoint, you can use instance endpoint. How Aurora data storage is built. Interesting point. Whenever, because while launching it didn't ask for any kind of storage. So when even though the Aurora cluster volume can grow up to 64 terabytes, you are only charged for the space that you use in Aurora cluster volume. So when the Aurora data is removed, such as by dropping the table or partition, the overall allocated space remains the same. The free space is reused automatically when the data volume increased in future. Storage costs are based on storage high water mark. What do you mean by high water mark? Like suppose I load a data of 10 GB. Tomorrow I delete 5 GB. Then sorry, I will be still charged for the 10 GB because I have already reached up to the higher point. Up to that I have used my data, and that is 10 GB. If tomorrow I am uploading the 20 GB data, so 10 GB already exists, 20 GB more, I am using a 30 GB. So it will depend upon the high watermark. How you will remove the high watermark? First thing is avoid ETL practices that create large volume of temporary data or load large volume or load large volume of new data which need to be deleted soon. Like, don't create Aurora cluster for temporary storage. Otherwise, unnecessary bill will generate for the storage. Or you kind of doing a temporary table you want to create in Aurora cluster. So suppose there is a flow in application that data is coming, you guys are doing some ETL operation and putting temporary data in Aurora cluster. Don't put like that, otherwise unnecessary, because the architecture is not like that. Our bill will unnecessarily generate for that. So we have to keep this thing in mind. Resetting the high watermark require doing a logical data pump and restore a new cluster using tools such as MySQL dump. That MySQL dump is MySQL utility. Create and restoring a snapshot, that is important point. Like if suppose there is a high watermark in one cluster, if you want to create a snapshot and restore somewhere else, that way high watermark will not go. Creating and restoring a snapshot doesn't reduce the allocated storage because physical layout of the underlying storage remains the same in a stored snapshot. Aurora Serverless, very simple. Suppose you are a DBA and you have to choose the instance type, how many read replica required, master and all blah blah you have to choose, and you have to launch the Aurora cluster. Instead of that, you can choose in service serverless. What do you mean by serverless? You have to put your database name and then launch the cluster. According to the workload, the cluster will be expand, and according to the workload, the cluster will decrease. Even it will decrease up to 0. How? And it also depend upon, because this feature, serverless features depend upon which MySQL version you are going to use. For MySQL 5.6 and Postgre beta, helpful when you can predict the workload. DB cluster start, shut down and scale automatically based on CPU connection. On the way to 0 instance depend upon the workload. Can migrate from Aurora cluster to serverless or vice versa. Aurora serverless uses is measured in ACU, Aurora Capacity Unit. So if you want to launch this Aurora serverless, you have to put Aurora Capacity Unit, and according to the capacity unit they have defined, like one capacity unit has a 2 GB RAM, this much of CPU, or 10 CPU unit is equal to 20. But just you wanted to know the basic RAM. If you want to change this, you can change it on fly. So some of the feature of Aurora are not supported in serverless mode. Be sure to check the documentation if you want to go to. Some of the feature doesn't support in Aurora serverless, and that you have to check documentation, some of the minor feature, but it is very good when you don't predict the workloads. You can launch it, see the workload, according to the workload you design Aurora cluster and you migrate it. That you can do it. Aurora serverless is based on some same database engine Aurora, but instead of provisioning some of the resource, it handles as a service. So if you are looking for an RDBMS database as a serverless architecture without a DB interface, you can use Aurora serverless. Data API in Aurora can be used only with Aurora serverless data architecture, and also given query editor only be used in Aurora serverless. We'll see this bit practically in our next session. So Aurora Global Database. An Aurora Global Database consists of one primary AWS region where data is mastered, and up to 5 read-only secondary region. So when you launch a regional database, in one region you will have a master, will have a 5 read replica, and you can have also the secondary read replica in another availability zone, or not in availability zone, another region also read replica can be possible. An Aurora Global database used a dedicated infrastructure to replicate your data, leaving database resource available entirely to serve as an application workload. Global means you can have a cluster in this region, you have a cluster in another region, but only one region the write will happen. Suppose I create a Aurora cluster and I am changing this as a global database. So my cluster will be in North Virginia, and another cluster will be secondary, will be you can create in Ohio, tertiary you can create in London, but the write will always happen to North Virginia region. Read will happen, and that is just for the data locality, and you can decrease the latency for data access. That's all things you can do with, that you can achieve through putting Aurora Global Database. Application with an worldwide footprint can use a reader instance in secondary AWS region for the low latency. So the master will be always present with the origin center where you have created your cluster. Rest of the secondary region, this all will be a secondary region also, primary region, secondary region, and the primary master will be always present with the primary region. In event of any issue, you can promote the secondary AWS region to take the full read write workload under a minute. Yeah, that is possible. Like even availability zone itself is not availability zone, region itself has something wrong. You can activate the secondary region to act as a primary and convert one of instance as a master master read write operation. Aurora Global Database use dedicated infrastructure to replicate changes between primary DB cluster and secondary DB cluster. So your latency will be very minimal if you want to propagate your data from one region to another region through Aurora cluster. If you create a secondary replicate, that have a different similar way, normal way to approach. But if you are creating a global database, they have a dedicated things to go with Aurora Global Database. Aurora Global Data is not available in some of the AWS region. You need to check. You cannot create a cross-region read replica from primary cluster in the same region as a secondary. That is important point. Like you launch your primary cluster in a primary database in a primary region. I'm taking primary region, or you can say North Virginia region. You are converting this database in a global database and creating a second cluster in Ohio region. Now up to this it's okay. But when you want to create a replica from primary cluster which is running in North Virginia, in Ohio itself again, it will not allow. But if you want to create a read replica to some other region, London region and South Asia region, you can do it. Means that secondary cluster and the read replica of same primary cluster cannot be exist in same region. Simple. So there is a limitation where there is a things you need to, there is a limitation. Our cloning is not possible, backtracing is not possible, parallel query Aurora Serverless is not possible, stopping and starting DB cluster within the global database is not possible. These are the limitation. Backtracing means if the database is global, you cannot backtrace up to previous time up to 72 hours. You can't. These things will not work. Parallel query, there is a feature, it will not work. Aurora Serverless activity, like you can launch Aurora Serverless, you can't do it if you convert your database with a global. You can't migrate into serverless. Stopping and starting DB cluster, you can't do it. You can't stop it. I have tried. You can try it. RDS Proxy. RDS Proxy is to maintain the connection in the pool to leave up to the some time when there is something happen wrong in a database. Very simple. If your application is connected to the Aurora cluster and the master goes fail, master will another read replica or another replica will convert into the master. Till the time there will be two possibility. Either the connection will be evicted, an application has to reconnect, or something can time out, or connection has to reconnect, or connection will be present there, and once the secondary replica will convert into master, it will make a connection. So to maintain that, either you have to create a dedicated infrastructure or connection pooling, or you can use the latest feature called RDS Proxy. So suppose you have an apps has a connection to the RDS Proxy, and using the RDS Proxy you can connect to the database. So it's a kind of balancing the connection. For what purpose? Application is scaling by pool and share connection with unpredictable workload, high connection open rate and idling connection. No infrastructure to use. Distributed workload across the availability zone to tolerate the availability zone outage. Like suppose you're obvious, you have chosen the reader, you can say a reader endpoint, and it is connected to one availability zone. If it is switching to another availability zone, maybe a connection timeout, it will not happen because it will handle through the proxy. Compatible with Aurora MySQL and RDS MySQL. So currently it is available with either Aurora MySQL or RDS MySQL, and it is, I told it is recently launched. AWS reInvent 2019 lab. So we'll go to the lab and see what is the status. We'll refresh here and it is available. See, if you go and click on here and we click the database, showing one endpoint because read and write is okay. Do one thing, I will go here in action. Let's go here because see, I was on instance. Let's go to the cluster and see this endpoint, reader endpoint, writer endpoint as a cluster level. Okay, this is called cluster endpoint. The cluster endpoint has read write operation. This is the reader endpoint. Okay, if you click here, this is the particular instance. It has their instance endpoint. This is the way. 3, 4 is custom, you can create it. If you go down, there's a way you can create it. If you click here on the cluster, if you go to the modify, add reason, see for the 5.6 it was showing that either regional and global, but after 5.6 if you want to go to 5, we have launched 5.7 MySQL. Here if you choose the SQL cluster, click action, add reason. When you click add reason, see global database setting. So option get change, feature will be available. See, option will get change, feature will be available. When you choose 5.6 while creating only, it will ask you are going to use regional or global. But if you choose a higher version 5.7 and all, you create a regional database. Database will be regional, it will be specific to one region, and then go to the option and add region. It will automatically convert into global database. This way database will work. Now if you see, now again go to this my cluster, go to action, now go to create cross region read replica. That is also possible. Create clone, you can do it. Restore to point in time. You can also use auto scaling read replica. Restore, you can restore to previous point. See launch TV. See, last restore is this because we have just launched. Am I right? So this is the way you can. Now how you to connect, I will show you. Either you can use MySQL utility, do you have, or MySQL Workbench. Let me launch the MySQL Workbench. Now MySQL Workbench you can download, connect to the database, and here what you have to do is you have to go to my ADB. You can put cluster, you can put writer endpoint, you can put host name here 336, password is root is equal to admin. Okay, and then create OK. It will ask password and click. So using MySQL Workbench you will be able to log in. Now we are able to log in. See, show databases. See, information schema, MyADB, MySQL, performance schema, sys, all you will get it. Otherwise, if MySQL, you can execute this. Now if you want to go and create any show tables, a lot of databases present, Aurora, S3, load history, bin, all. If you want to create your own table, you can create it. Okay, I don't have access because I need to check, I need to create my another database, or like that you can do it. You can create it. Or you can use another command, create database test db. Now good, then use test db. I want to do DDL operation, see here, and in that you can create your table. See, and you want to create another table. I have already written this. You create another table. No, and then you can use show tables. See this, contact one and my table. Interesting part is that what I will do is I will create another connection. Okay, I will create another connection. This is with a reader endpoint. Okay, it will ask for the password. Now here, because I logged in as a reader endpoint, I will use so because I know use database, use testdb. I will execute this. Now show tables. I think it's table. So tables. Interesting part is that can I create a database? Create a new table. Let's go here and my table 1 2 3. You do it and let's see if I'm able to create it or not. Let's create it. Okay, I can do this because I'm connecting to the same instance, because the same instance is a read write permission. That's the reason even if you have a single instance, either use reader endpoint, it will work as a read write. Okay. So takeaway from the session is Amazon Aurora is a fully managed relational database engine that compatible with the MySQL and Postgre. The underlying storage growth automatically as needed up to 64 terabyte. Aurora storage automatically grow in increment of 10 GB up to 64 terabyte. So like 10 GB, 10 GB up to 64 terabyte it will allocate. I mean, you don't have to do a provisioning. Storage contains 6 copy of your data across 3 ability zone and 2 copy in each ability zone. 3 copy out of 6 is needed for the read operation and 4 copy out of 6 is needed for the write operation. In Aurora Serverless, DB cluster start, shut down and scale automatically based on CPU and connection. You can migrate from Aurora cluster to serverless or vice versa. But yes, you need to keep all the things in a point, like what are the limitations. If a cluster is global, you can't convert to serverless, and if you are in serverless, what are the some limitation present. Next topic we are going to discuss about operational activity in AWS Aurora and the lab on it. Thank you. Thanks again. Let's keep learning.